Okay, good afternoon, everybody, and thanks for attending. I know it's late in the afternoon. So my name's Paul Hewitt. I look after the data and analytics practice at Luxoft, and we're proud to be a partner with Dataiku. And one of the things that we're seeing increasing volumes of business in, obviously, is making sure that we can use Dataiku in a business context and not necessarily just in an R&D type of context. So we've done quite a few data analytics-based solutions, both for ourselves internally as a company. You know, we're a reasonably large consultancy and part of a much bigger global consultancy called DXC. And in this presentation, the idea is just to go through some of the key success factors for commercially successful implementations. Now, it's kind of true to say that as a data scientist, analytics and machine learning is really the thing that gets us out of bed, and it's the fun bit. But for successful delivery and making sure that the business clients that we all have at the end of the day are happy, we also need a bunch of other things. So in particular, strategic alignment. We need to be sure that we're on sides with what the business is looking for as well. Increasingly important these days for everybody is the architecture and the integration side. At the end of the day, if we have a POC, that's good, but it doesn't complete the picture. And then lastly, and perhaps often overlooked also these days, is the process and the operations behind the data science. So it's not just enough to have the tech and the integration. It's also really important, increasingly, to have correct processes and operations behind it. So I'll touch very briefly on each of those areas. So there are sort of about 10 or so non-title slides, and go through each of the fairly high level. And of course, if you've got any questions or any comments or anything afterwards, please feel free to reach out and contact any one of the team. So starting off, we'll look a little bit at the background. So the focus here is successful commercial usage of advanced analytics. So what we all start out with is the POCs, the proof of concepts, and the proof of values. And there's quite a common sort of anti-pattern in all of this. You know, all too often, what happens, with us and with everybody else is we take a slice of the data. We get some models going as a consequence, but putting that into production is a very small part of the overall picture. I think it was a famous quote from Google a couple of years ago. Any successful machine learning project has only about 5% machine learning in it. The rest of it is all the other parts, data and data wrangling in particular. So the data science is fundamental, but to get it into production, there's a lot more to the overall picture. So starting off, first of all, there's the data journey, perhaps, the overall process or progress towards AI and machine learning at an enterprise sort of level. That basically means most people at the end of the day want to get to a point where you can use data analytics for decisioning, make better informed decisions as a consequence of your AI and machine learning. And to get there, there are a couple of prerequisites. The data management is kind of obvious. Snowflake is here, and the data storage is fundamental, and data management is fundamental. We won't go too much into that. But probably the first sticking point that commercially we almost always encounter is getting consistent and coherent data models. Now, it's kind of not necessarily the most, what's the word for it, glamorous part of the operation. But if you cannot get a commercial model, data model, that makes sense to the business, there's not much point in progressing further. So by that I mean, if you make the data available to the business, it has to do what it says on the tin. So it has to describe itself correctly. And if you make it available via a self-service type of package to the business, they need to be able to use it successfully. So it needs to be complete, coherent, and self-descriptive. And if you can do that, the acid test is if you can show that to people via the self-service package, whether it's Dataiku, Power BI, Tableau, any of those, If you can make the data available to the business and the business can use it confidently, you've got a situation, you've got something that will go viral reasonably quickly. We've had situations where we've been told to expect 15 users, but because the data model was built correctly, we ended up with about 400. And not because somebody said, thou shalt use this, but it was because people came and said, we want to use it, it's correct, can we have access? So the data model is pretty fundamental. And another way of putting it is that you can't expect to have enterprise-wide analytics if you can't have something that's comparatively more simple, like self-service analytics for the business. So the data model for us is a key gate to being able to do enterprise-wide, commercial-grade analytics for everybody. So that's the key point, I guess, out of this slide, is that the self-service component, although it's not necessarily directly a technical component, the self-service side of it is a key commercial success factor to getting your analytics rolled out across the enterprise. So there's a slide here with a little bit more detail, and that's basically just going through each of those pillars in slightly more depth. But I guess the basic point is that there are a bunch of things that are often taken as self-evident. For example, it's always taken as self-evident that you should have a data lake. Why should you have a data lake? Well, the reason you should have a data lake is because it's cheaper for your analysts at the end of the day to connect to one place than it is to connect to 40. And we have got clients who've got 400 separate data sources going into their data lake. And it becomes completely unmanageable if you don't have consistent processes and consistent ways of getting the data in. Operationally, the cost will kill you further on down the line if you don't get standardized right up front. So those are the first two pillars over there, the consolidation, the democratization, and the visualization we've been through already in the self-service. If you can't do the self-service, your chances of doing enterprise-wide analytics are pretty much zero. And once we get to the advanced analytics, that's where packages like Dataiku really come into their own. So that's a little bit more detail on the packages. There are a bunch of current issues that need to be addressed for commercial success, and I'm not going to go through all of those. They all are large topics in their own right. But we all know about the different pushes at the moment that the regulators are making. There's a lot of focus in the industry on regulation, fairness in AI. So it's not just complying with the regulation, but making sure that internally you are doing things correctly and ethically. And one thing that also is maybe not stressed as much as it perhaps should be is that there's a direct link between the IT and the data analytics, and the two, in a sense, are kind of a crossover. So we've got, we all know about ML operations, and ML ops is becoming a thing in its own right. But not only is ML ops important, but also the whole test side is important as well. So there's been a lot of progress in recent times about making sure that you monitor the metrics and the bias and the drift, and you keep on top of all the errors and so forth. But also increasingly, analytics is becoming real-time. So if you're doing real-time analytics, the test side becomes really important. The load running, load balancing becomes really important. And we're seeing quite a lot of progress in things like setting up large-scale synthetic data sets so that you can test the data at scale before you actually roll it out, and pre-populating data with features that you want to detect as you go along and testing it before you actually implement. So again, each of those pillars is a full discussion in its own right, and there's a lot of continual development going on in all of those. The next stage, perhaps, or the next broad area to talk about is the architecture and the integration. There, I think it's maybe the fairly widely known general architecture, usually it looks something like this. You've got one data store sitting at the heart of it all, and it can be Snowflake, it can be Oracle, it can be just about anything, really. I mean, Dataiku is good at connecting to most stuff. But again, usually, large-scale commercial data sets, you've got a couple of different conceptual segments, at least. You have a staging segment where the data comes in. You've got an ETL, which produces your final data model. You typically have a visual analytics platform that might or might not be the same as Dataiku. Oftentimes, people use Power BI or Tableau or QuickSight, I suppose, more recently. Oftentimes, you have a separate visual analytics package, but again, the principle is much the same. But overall, your architecture looks something like that. What isn't shown there is the client side. So for a commercial application, you always have a client calling your models one way or the other, whether it's via REST APIs or whether it's part of a batch scheduling and batch scheduled job. So that's overall typical architecture, and there should be nothing too unusual in that. And peeling the onion in a slightly different way, at the heart of it all, you've got Dataiku plus a storage solution plus a visualization solution. Sitting on top of that, you've got your business use cases, which is where I think most of us spend most of our time, solving problems, producing models, and so forth. And the last layer right at the outer edge is the UI and client application. Now, spending a moment or two on the calling client side, you've got two sort of fairly common use cases for commercial usage. The first is that you integrate to an existing application, and REST is very useful for that. So you'll have an existing application calling a REST API, and it's quite an easy integration. That's one way. Another way is that you simply make the model running a part of your batch run every day. That's another simple way. And the third, increasingly common paradigm these days, is that there's a new user interface required or some new user interface aspects required. Now, in this day and age, most users don't want to wait for 6 weeks for 3 sprint cycles before they get the new application. So we're seeing increasing usage of low-code platforms like UiPath, Pega, Appian, Blue Prism, all of those sorts of things, which give you very quick and production-grade user interfaces very fast, which are then very easy to integrate into Dataiku and into your model engine backend. So that, I guess, is the overall theme over there, is that to the extent that people want, let's say, a better integration than what they've got already, there's a lot more usage of the low-code platforms to do that integration for them. One aspect also that is often overlooked, it can derail the whole thing is well, maybe let's just stop for a minute on the, just generally speaking, on processes and operations. You can do all the tech correctly. You can have a good architecture. You can have great models, et cetera, et cetera. You can still have very unhappy users if the processes are not correct. And by the processes, I mean, if you want to put something into production, in almost all organizations these days, you've got to go through a change control process. And again, if you're saying to traders, for example, wait for the next sprint cycle before you get a new report showing the impact of the latest Fed announcement, if you say to them, wait for 2 weeks, you've lost them. You need to be saying you can get something into your prod environment in 2 hours, not 2 weeks or 3 sprint cycles or whatever the case may be. So it's also critically important in many instances, not just to change the architecture and change the models, but also to change the processes and make sure that you're getting things into prod safely and really quickly. And that takes often a bit of doing. So for example, if you want to put a new dashboard into prod, and you've got really big data sets, you can't have somebody by accident doing a 1 billion by 1 billion many-to-many join, because that's going to kill your warehouse. So you've got to have both the IT side fast enough to sign off, and you've got to have the business side fast enough to sign off, and you've got to be able to put those two things together to get into prod as quickly as possible for the environment. So that's sort of the background why there's a lot of focus on the overall prod environment. And I guess just as a general model, everybody's a little bit different. We tend to follow, you've got a data life cycle and you've got an analytics life cycle. Data life cycle, oftentimes, a trader will want something new in terms of new data or new provider. Alternatively, if you're doing ESG, that's a very fast-changing area these days. I mean, the time constraints are not usually as drastic as the capital markets. But nonetheless, the overall approach on the data side is kind of the usual data life cycle that most of you will be familiar with already. The acquisition, the consolidation, governance, and democratization. Those you've got to get quick, and also you've got to get the final artifacts quick as well. Lastly, on the process side, just coming back to developing it in the first place, we tend to use CrispDM, and most of you will be familiar with it again. I know it's a fairly old methodology, but the major advantage of it, especially for business users, is that it's simple. You can divide it up into clear-cut stages, and it becomes something that is easy to track, easy to manage. And as long as you do it correctly and adhere to the discipline, it becomes a pretty good documentation set for later on. So we tend to follow it. I mean, there are other methodologies as well, but this is well known and relatively easy. And one of the crucial factors, at least, to getting to prod on your first instance. Later on, it becomes quicker. Change control process is a bit leaner. But this is a good way to start with the initial development. Then also, it's worth saying, again, from an IT context, is that CrispDM or any other methodology that you use is not exactly the same as a project management methodology. Usually, especially if it's a bigger project, you want to integrate it with your existing internal or the client's internal project management methodology. Most people these days use SAFe or Agile or some variation thereof. So the main function of the CrispDM methodology or your data lifecycle methodology is to provide stories and to structure those stories, but those stories in turn then go into the usual project management framework that you use already. So it's just to show how the two integrate. It's not a project management methodology, CrispDM. It's a way to generate stories that then go into the project management methodology and become part of your overall delivery. Right, and then if you put all of those things together correctly, here's a quick example of a couple of screenshots from a POC that we did fairly recently, and you want to end up with something that kind of looks more or less like that, or has some of those things built in. It's an integrated platform. It looks pretty seamless to the user when they use it, but you've got the Dataiku pipelining that's part of it all. You've got a user interface that was built in a couple of weeks using Appian that integrates with the Dataiku engine at the back end. Looks pretty neat. And then lastly, also, you've got extensions built into Dataiku. So in this case, it was a fraud detection application. So there are a bunch of fraud rule generators built in, and those become part of the data pipelining canvas in Dataiku that you can use as part of your drag and drop. So I guess overall, what I was hoping to show you is just what the success factors are for building all of those things. Apologies, we have an obligatory sort of marketing slide at the back end there, and that's what makes all these things work. It's a combination of analytics, the engineering and the IT side, and then lastly also domain knowledge always is important for delivery. And that, I think, is what I wanted to cover. So thank you very much for your time. Thank you for listening, and hopefully I'll get to meet more of you later on. Thank you.